Hello everyone, welcome to my channel. So in this video we'll be learning how to make a box plot. But before that, first let us understand what is a box plot. So a box plot is basically a way to summarize the distribution of a data set, and with the help of a box plot you can actually find out the range and the middle half of a ranked data set. A ranked data set in the sense a numerical data set, you can say. So for example, here we have taken some data set, like some data set that contains all these points, and now I'm going to make a box plot over here. So the first step that I'm going to do is I'm going to find the median of this data set. So when I find the median, suppose the median is somewhere over here, so I'm going to draw a line over here. So I found the median that lies somewhere between 4 and 5, and since the median is over here, it means that this part is 50% of the data set, and the remaining this part till the last point is the remaining 50% of the data set. So basically this line, that is the median, is used to divide the data set into two different equally different parts. Okay, now after finding out the median, I am going to take the first 50% half, and now I'm going to further subdivide this into another half part. Okay, so since it is 50%, I'll further subdivide it into half, so it will become 25%. So from here, if I find the median somewhere like around 25% over here, then I'll draw a line. So this part basically from here to here becomes my 25%. Okay, and the same thing I'm going to do for my other half, okay, the second half of 50%. So here also I'll draw a line, and then this too becomes my 25%. Okay, so now I've got these three lines. Now I'm just going to join them, and this becomes my central box of the box plot. Okay, so in this central box of the box plot, this middle line represents the median. Okay, that's my median, and the first line which you can see, that is my 25 percentile. And the other line, okay, since the 25th percentile, then came the median, that was the 50% part, then we had again taken another 25%, so it became my 75th percentile. Okay, so I've got here my 25th percentile and my 75th percentile. Now what is this, my 25th percentile? That is known as my lower quartile. Okay, that 25th percentile is known as lower quartile, and the 75th percentile is known as upper quartile. Okay, so in the central box of the box plot we have got three different units, that is the lower quartile, then the upper quartile, and the median. Okay, so these three units are in the central box. Now I'm going to draw the whiskers. Okay, the whiskers on the left and the right side of the central box. So what are whiskers basically? For that we need the inner quartile range. Now from here to here, this part, that is from 25th to 75th percentile, that part is known as my inner quartile range. Okay, so this part is known as my inner quartile range. Now I'm going to use this, and I'm going to draw my left and right whiskers. So my left and right whiskers both are going to be around, they will be 1.5 times of inner quartile range. Okay, right, so both the sides I got my left whisker and my right whiskers, and they both are like 1.5 times of my inner quartile range, and the end point of this left whisker will be my minimum value, that is it will represent my minimum value, and here I'll get my maximum value. But as you can see, there's one point over here which is outside the right whisker part. So there I'm going to draw another point, and this will become my outlier. So outlier is nothing but, you can say that it is an observation that is, numerically distant from the rest of the data. So this is what your basic box plot looks like. So now we are going to basically plot this with the help of Matplotlib in Spider. So basically this full box plot is known as a 5 number statistical summary, and that's because we have got here 5 different elements. Those are the minimum value, the maximum value, and then we have got 25th percentile, median, 75th percentile, that is the lower quartile, median and upper quartile. So basically we have divided the whole box plot into 5 different elements or 5 different components, you can say. That is why it is also known as a 5 number statistical summary. So now let us see how to plot a box plot using the Matplotlib, and we will be talking about the different parameters that we are going to use while plotting this. So first let us plot a plain box plot. So as you can see, I have already imported the matplotlib.pyplot as plt, so that I need not write this whole thing again. I can just write plt in short, and I have taken a list of values. Now I'm going to plot my box plot. So I'll just write plt.boxplot, and in that I'm going to pass the parameters. So you can see here we have got different kinds of parameters that we can pass here. So first thing is the x, that is the basic values, the set of values that we want to pass. So here, as I have already taken a list of values, I'm going to give the name of the list, and then I'll write plt.show, and now I'm going to run it. So as you can see, we have got here our basic box plot. This part is the minimum value, this is the maximum value, and this first line will represent our lower quartile, the upper one will represent the upper quartile, and the middle line, which you can see, is our median, as we have talked before. So this is our basic box plot. Now let us try to add some features to it. Okay. So first, now basically if you want to find the mean value also in your data set along with the median, then you have got a parameter which is called show means. So what you need to do is write show means is equal to, now I'm going to write show means is equal to true. Okay. Now, as you can see, we have got here a point, a green color point, which basically represents our mean value. Now you might be thinking, why is it that I have written it as show means is equal to true? Now that's because show means is by default it is false. It basically means that it is not showing the mean value. See, when I have printed a basic box plot, did I get the mean value? No, right? I got the median value, but there was no mean value. So show means was basically false by default. Now I made it true by giving this parameter that show means is equal to true. So it started showing me the mean value. So like that you can give different parameters. Now I can give another parameter called mean line is equal to true, and then run it. So now you can see here that the same mean value, that is, if you see, this one is my previous graph. In this the mean value was represented with a point, but if you want the mean value to be represented with a line like this, then you can give another parameter which is the mean line, and then you just have to write mean line is equal to true. So basically whatever parameter you're giving, that is whatever parameter you want to show on your box plot, you have to make it as true. Sometimes the parameters are by default false, and sometimes by default they are true also. Okay, so we'll see the different scenarios. So in this case, both the show means and mean line, by default they were false. That's why we were not getting a mean value. So here we made these parameters true. So that is about the mean value. Now let us go on to our next parameter, and that is our notched box plot. So I'll write notch is equal to true. Okay. Now you can see here I have got a notched box plot. So by default this notch was false. Now it basically means that I was getting a simple rectangular box plot, but if you want a notched box plot, that is has got a demarcation at the median line, then you can go for this parameter where notch is equal to true. Okay. Now our next parameter is about the central box. So if I give the parameter like showbox is equal to false, so this time I'm giving a false parameter. That means by default this showbox was true. So what it means, now it is evident from this output that showbox here represents our central box. Okay, this part was our central box as I told you. And now when I did the show box is equal to false, that means I don't want the central box. I want the basic values that we were getting before, that is my whiskers, the left whisker, the right whisker. I want the median line also, but I don't want my central box. So for that, what I'm going to do is I'm going to pass the show box parameter and I'm going to make it as false. By default, this parameter was true. That is why we were getting the central box. But now since I made the parameter as false, we are not getting the central box. Okay. Now next parameter is about the orientation. So if you see our previous outputs, you can see that our box plot is in vertical position. If you want to make it in horizontal position, you have a parameter. This I'm going to make it as false. Okay, so as you can see, if this parameter word is false, that means it would show the output in a horizontal position. Okay, it will show the box plot in a horizontal position. By default, this vertical position was true. That's why we were always getting the box plot in a vertical position. But now, since I want it in a horizontal manner, I'll make this parameter as false. Okay, so this was about the orientation. Now, another one is the patch artist. Now, this box plot, as you can see, the inside part is empty. So, if you want to make the inside part as highlighted or you want to fill it with any color, then you have got a argument, a parameter, which is known as patch artist. Okay. Now, this I'm going to make it as true. So, I hope you're understanding the basic ideology behind this, that whatever parameter you want to show, you're going to make it as true. And whatever you don't want, basically you make it as false. Okay, so now you can see here we have got a box plot with the filled color inside. So this is about the patch artist. That is, if you want if you don't want this kind of simple box plots and if you want a one with filled color, you can go for this parameter. Okay, now suppose if you want to plot multiple data sets, like if you want to plot multiple data sequence in the same box plot, but with individual labels, that is, you want two different box plots on the same graph. So that how you're going to do. So for that, let me import NumPy also. I'll import NumPy as NP. I already have one list, and now I'm going to make two arrays from this. Okay, and I'll make it as np.array, and in this I'm going to pass my parameter. Okay, so this is my first one, and then my second one will be array 2. Now let me make my array 2 as let me take the elements from array 1 and multiply it with some number. Okay, so this becomes my array 2. Now in case of this X position, now since I've got here two different arrays and I want to plot both of them in the same graph, so I'm going to represent them in the form of a nested list. So I'll make a list over here. In that I'll pass both the array 1 and 2. Okay, so this is my nested list with both the array values. and I'm going to plot this. So this is how you can get two different box plots, that is with two different data sequences, and you can actually use them to compare two different data sets. Okay, so like this you can plot multiple box plots also on the same graph. Now let us plot one box plot with all these kind of different parameters. Okay, so I have taken here a data set. Let me use this data set. Okay, so I've got here my data set. Now, since like in the previous situation, I made a nested list of both those two arrays. So in this situation also, I'm going to make a nested list of all these three different lists that I've made. So let me make it as my final list, and it contains all these three lists. Okay, so this is my final nested list, and now let me just plot my box plot. Okay, so now this time I'm going to, instead of writing the nested list, I have made a separate list. I'm going to pass that parameter only over here. Okay, so this becomes my basic data set. Now let me make the patch artist as true only. Okay, so that I get the color inside. Then the next thing that we discussed was notch. And let me make this as true also, so that I get a notched box plot. And then next thing which I'll take is, let's take the orientation. What is equal to false. Now, okay, let me take 0 this time. Now, as we know that in Python, like the 0 represents false and 1 represents true. So instead of writing here true and false every time, you can even pass the parameters as is equal to 0 for false and is equal to 1 for true. Okay, so you can do that also, whichever way you're comfortable with. So this is about the orientation. Then if I want the mean value, okay, so I'll use show means is equal to true. So okay, so for true, let me pass 1 this time, since we know that 0 represents false and 1 represents true. So I'm taking 1. Now let me take mean line, because I want my mean value to not be displayed with the help of a point but with the help of proper line, just like my median. So I'm going to make this also as true, and I'll write 1 again. Okay, now since we have taken here three different lists, so in order to identify them, like how here it is showing as 1 and 2, but I wanted to know which type of data set it is showing. So for that, I'll use my labels option. Okay, I'll use this labels parameter, and in this I'll make a list and I'll give the names. Okay, let me give it as day 1, day 2, day 3 only. Okay, so here comes my labels. So this is like the basic thing which I'm going to give. And now you can even add a title to your box plot by giving this parameter of plt dot title. Okay, and let me put the title as let's say prices. Okay, now I'll do plt dot show. Right, so you can see here we have got here three different box plots, and we have got here their respective labels also, that is day 1, day 2, day 3. So by that we can understand that these three box plots, they represent these three sequence of data. And since we gave patch artist is equal to true, we got colored box plots. We gave notch is equal to true, so we got notched box plots at the median position. Then we gave show means and mean line. So here the mean value is represented with a proper line, just like our median. And next was labels. So labels is also there. Now since you can see this is like a kind of blurry box plot, so let me change its figure size. So this is for that I'll use the fix size option, plt dot figure. Now this kind of this figure option, this can be used for other kind of plots also. Okay, so let me take the fixed size equal to 10 comma 11, 10 comma 7. This will be okay, I think. Okay, so now you can see this has become a little more clear. This was the previous one and this is the new one, so it has become a little more clear. So this plt dot figure can be used for other kinds of plots also. So you can use it to change the size of your box plot, okay, the dimensions, and it will look more neat. So this is how we make a box plot. So I hope everything is clear now, and if you have any doubts, you can let me know in the comment section below. So thank you for watching and meet you in my next video.